Hi guys, I'm Ankit. In this video, we shall see another problem on LeetCode. The question is maximal square. So given m cross n binary matrix filled with zeros and ones, find the largest square containing only ones and return its area. So what they say in the given question is they are given a 2D matrix. It's a binary matrix. That means it contains only zeros and ones, and we have to return the maximum square that's present. The maximum square form is the boxes with only ones. You could see here 1, 1, 1, 1. So this is the maximum square you can find. And return its area. Area means how do you find the area? The length is 2, 2, 2 into 2, 4. 4 is the area. This is what we need to. So what is the approach to solve the problem? We'll see. So first, I just take an example like if you have a box like this, okay, 2D matrix, and here 0, 1, 1, 0. So a single box can be a square? Yes, it can be, right? Because equal length and breadth. A square is nothing but both length and breadth are equal in that case. So if it is 0, this cannot be a square. No. If this is 1, yes, this single box can be a square. Here also it's 1, this single box can be a square. No, this cannot be a square. How do you find the biggest square? So let's take another example, okay? Where all the elements are 1. We take this single box, yes, this is a square, this is a square, this is a square. But when you have this is a square, but can there be any bigger square than this? If you see the above part, this part, diagonal part, and the above part, all are ones. That means this can be a square, right? Let's say we have 3 cross 3 matrix. In this case, let's say all the elements are 1. So in this case, the single all the single boxes are squares, and 2 cross 2 square also we can form. This is a 2 cross 1, and 3 cross 3 is this one. So but how do you get this 3 cross 3 biggest square? So for that what we do is we'll keep an another 2D matrix of same thing, not 2D matrix, yeah, 2D matrix of 3 cross 3. Okay, and here you check this element is 1. Yes, if this is 1, and just initialize to 1. If this is a corner in case, okay, all the corner elements, this is 1, 1, 1, 1. That means the first row and first column, you just fill the values as in if it is 1, then make it as 1, otherwise 0. When you come to this box now, here this alone can be a single square. The other square can be 2 cross 2 for this. Either this is 1 square or this is 1 square. But how do you get to know whether you have this bigger square or not? For that you have to check whether it's neighboring elements. Here neighboring elements is 1, 1, 1. So if these are 1, that means what? If all are 1 and this is also 1, that means this can be a square. So in the DP array, you check DP of I comma j will be equal to DP of I minus 1 comma j, then DP of I minus 1 comma j minus 1, and DP of I comma j minus 1. So I minus 1 comma j means one row above this part. I minus 1 j minus 1 diagonal. I comma j minus 1 will be this. So if all these three are 1, then only, and this is 1, then only this will form a matrix. So if dp of I comma j equal to 1, so if the matrix given matrix is equal to 1, and dp of I comma j will be equal to minimum of all three. So why am I taking minimum? Because so minimum of all these three is how much? 1, 1, 1. That will be 1 only. So 1 plus this 1. So there should be plus equals to minimum of. So dp of I comma j will be initialized to 1. Is 1. dp of I comma j is equal to 1. Why is it equal to 1? Because the element is position is 1. And you find the minimum of all three. So minimum of all three, how much it is? 1. So 1 plus 1 we get as 2. So dp of I comma j, this position, the value get upgraded to 2. So I'll just rewrite the matrix again. So why are we taking minimum? I'll explain that. Okay, wait, I'll explain that. So currently we have 1 1 1 1 here, 1 here, 2. So logically we have to move like this, next this, and next row. But okay, since as I said, for the first and first column there is no square above this or below this or diagonally to this. So just you take this, and now you move to this position. Again you check. Here we have 1. So dp of I comma j will be 1 plus minimum of all three. How much it is? 1. So total of this will also be 2. So what does this 2 indicate is at this position you will get this 2 cross 2 matrix. At this position you will get 2 cross 2 matrix. Okay. Once you are done with this, now you have to move to this position. Again check here it is 1 and dp of all the three diagonal up and down, the minimum is 1. 1 plus 1 will be 2 here. So that means here 2 cross 2 matrix can be formed. That is the maximum square matrix at this position. And if you move to the last element, here we have 1 and the neighboring are all 3. The minimum of all 3 is 2 only. 2 plus 1 will be 3. So now you can get the maximum is how much you are getting, 3 cross 3 matrix. So we have to return this 3 cross 3. So you have to keep a variable called max size, and each time dp of I comma j and the max size you have to find the maximum. So why are we taking minimum? You could say actually if here it was 1, how can this be 1 here? So in this position we will have 1. Let's say this is 0. So this is 0. If this is 0, all three are 1. Then is there any matrix possible in this? No. Okay, not 0. Let's say this is 0 and this is 1. So if this is 1, you have to look for the neighboring things. Here 1, so this will be 0 because no matrix can be formed because here it is 0. So 0, 1, 2. What is the minimum of all three? That will be 0 only. So the answer will be 1 here. Why? Here you cannot form 2 cross 2 matrix because this is 0, right? So that is the reason we have to calculate the minimum of all three. If we take maximum like 2, if we take 2 plus 1 will be 3. Can there be 3 cross 3 matrix formed here? No. So you need to take minimum. Apparently we are just looking at this position. Is there an up, low, diagonal? No. So it will be 1. Okay. Then you move here. Up, diagonal, nothing. But low. This side we have what do we have? 1. So but minimum is nothing. So that's why I said all the first and first column you just initialize to whatever elements present. But when you come to this position, here you have to check whether this is 1, this is 1, this is 1. If all are 1, then this will be 1. If all are 2, then this will be 2. If this is 2, 1, 1, then 1 only will be taken. 1 plus 1, 2 will be taken because 2 cross 2 matrix can be formed. So this is how the dynamic programming approach will be implementing here. So we are just looking for the diagonal element, up element, down next element. If all are 1, then only this can be a matrix. That is a basic logic file. So if this can be a matrix, this will be, we initialize it to 2 because this is a 2 cross 2 matrix. Next, when you come to this position, here also 2 cross 2 matrix, here also 2 cross 2 matrix you get. So the here this indicates here 2 cross 2 matrix present, here 2 cross 2 matrix present, and here one more 2 cross 2 matrix present. So yeah, 2, 2, 2 here we have, and here we have 1. If we have 1, see, this can be 2 cross 2 matrix. This indicates, what does this indicate? This is a 2 cross 2 matrix. What does this indicate? This is a 2 cross 2 matrix. So when you come to this position, can this be entirely 3 cross 3 matrix? So that is where we are looking. Minimum of all three. What do we have? 2, 2, 2. That is 2 plus 1. So we get 3 cross 3 matrix. This is the logic behind the problem. So we shall program this. So let's say int m equal to matrix dot size. Similarly, columns we have to do matrix of any one of the row we take dot size. Next, what we need to do, we'll have a variable called max size initialized to 0, and just as you know 2D matrix, so we need to have two for loops, one inside the another. Another is a, let's initialize it to j, so let's say the n j plus plus. Okay, so have to check if matrix of I comma j, if it is equal to 1, then dp of I comma j will be equal to 1. Then to check the previous elements, when do we check for the previous elements? Only if it is not a first row and first column, right? So here we have to check if. So this if will be inside this only. Why? Only if dp of I comma j is equal to 1, then only we look for the neighboring elements. Otherwise we don't look. So if I greater than 0 and j greater than 0, that means only for the inside elements. We don't take into consideration first and first column. So if that is the case, then dp of I comma j plus equals to 1 will be already there, 1 plus the neighboring square whatever you get. That will be minimum of dp of I minus 1 to j comma dp of I minus 1 and j minus 1, then dp of I then j minus 1. Top, left and diagonal. So yeah, and each time what we need to do, we have to calculate max size. So max size will be equal to max of dp of I comma j comma max size. And at last we need to return the max size. Yes. Uh, for okay, I initialize j. So yes. Okay. Where did I tell the array? So vector int dp of. Okay, wait. So this initialization should be vector inside a vector. That is 2D array. dp of m comma for column again vector int of n comma 0. All initialized to 0. Yeah. So here again one more minimum I have to tell. So since it's taking 3 parameters, which cannot be done, only 2 parameters we can pass in. Any mistakes? Matrix of vector in. Okay. So since I have mentioned this is a character, instead of 1 this should be 1. And then anything else, max size. Okay, return the area. So area means max size into max size, because row and column size will be equal, as you know, in the square. Yes. Yeah. And for Java also same logic. 2D array you create and same thing will be applied. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in the next session. Till then, keep learning. Thank you.